pupils, humans and bugs. I'm Brina the Butterfly, and it is my pleasure to introduce Excellent Exoskeletons, a mind-blowing video tutorial about the billions of tiny colourful creatures living all around us. Presented by creative entomologist Nessa Darcy. Insects are the largest and most diverse group of living things on Earth and live in nearly every habitat on the planet. Nessa has studied them on the riverbanks of the Dodder, the heathlands of Howth, and the coastal forests of Madagascar. But we need look no further than our own back gardens and parks to see how these little ecosystem engineers keep the environment healthy. From pollination to waste disposal, and from nourishing the soil to inspiring design, insects provide humans with a vast range of services. Without them, the whole ecosystem would unravel and we simply couldn't survive. Besides everything they do that helps us humans, insects should have the right to exist for their own sake too. But we are bringing about their decline through pesticide use, habitat destruction, climate change, and over-tidying our gardens. That makes Nessa Darcy sad. And that's why she has made it her mission to show people the beauty, skills and personalities of bugs. She wants to make you fall in love with them and learn to understand what they need. Normally, this involves taking people outdoors to explore the habitats where insects and other invertebrates are abundant. Using a sweep net, she'll brush a whole bundle of bugs, spiders and caterpillars out of a hedgerow to show you how much life exists unseen around us. Sometimes her day is spent chasing bees and butterflies around a flower-rich grassland with a net. She puts pitfall traps out overnight to catch lively ground beetles and bumbling woodlice to bring into the classroom and admire under a microscope. She's currently surveying moths in County Offaly, collecting baseline data for biodiversity-friendly farming at Cool Eco Community. The moths flock to the light of her moth trap and roost inside to be identified in the early hours of the morning. Nessa also loves to make art about insects, to show people how beautiful they are close up and help us learn from bugs by observing them. Sometimes she makes videos, such as her recent tutorials about ground beetles on the Heritage Council's YouTube account. So, what can you expect from this video? Nessa is going to take you on an adventure into the world of bugs, introducing you to quite a few charming characters. You'll learn what an invertebrate is and what characteristics make an insect an insect. You'll discover what it's like to have your skeleton on the outside. You'll take a look at the different numbers of legs that different bugs can have. You'll follow a caterpillar through the process of metamorphosis and learn about the threats it faces along the way. You'll find out what different insects eat and how. And you'll hear about some weird and wonderful survival tactics. So, without further ado, let's go to the lab, where Nessa is examining some beetle specimens in preparation for this talk.
Hello there. I'm Nessa, and I'm a creative entomologist. My mission is to reintroduce humans to their natural habitat through colourful encounters with insects. This includes surveying habitats to protect wildlife, teaching people about insects through nature walks and workshops, and making art to celebrate the beauty and usefulness of insects. I spend a lot of my time frolicking around fields and woodlands, catching bugs, identifying them, and then telling landowners how to protect their habitats and the flowers and plants and other insects that they need to eat in order to survive. So what is an insect? Insects belong to a group of living things called invertebrates, animals without backbones. That group is split up into smaller categories, and insects fit into a group called arthropods. All arthropods have jointed legs, a bit like robot limbs, and their skeletons are on the outside. These are called exoskeletons. Arthropods include things like spiders, who have 8 legs, woodlice, who have 14 legs, and a whole bunch of crazy other names. But how many legs does a millipede have? Well, their name means 1,000 legs, but actually millipede species have between 24 and 750 legs. Still, that's probably enough. Centipede species, whose name means 100 legs, can have between 30 and 354 legs. So you can stop counting now. The way to tell the difference between a millipede and a centipede is this. Millipedes have 2 pairs of legs per segment of their body, and centipedes have 1 pair of legs per centipede per segment of their body. It's a bit of a tongue twister. How many spots do you reckon a ladybird has? Well, just like millipedes and centipedes, it depends on the species. And look how many species we have in Britain and Ireland. So, a 2-spot ladybird has 2 spots, a 7-spot has 7, a 22-spot has, well, you get the picture. So how do you tell an insect apart from the other arthropods? Well, all insects have 6 legs. Their bodies are divided into 3 segments: a head, a thorax, and an abdomen. I think I have a song for that.
Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. 6 legs, maybe wings, and a pair of antennae. Head, thorax, abdomen, abdomen. Let's try it slow so we can all sing along. Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. 6 legs, maybe wings, and a pair of antennae. Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. 6 legs, maybe wings, and a pair of antennae. Head, thorax, abdomen, abdomen. Faster. I'm tired. Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. 6 legs, maybe wings, and a pair of antennae. Head, thorax, abdomen, abdomen. Slow it down.
Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. 6 legs, maybe wings, and a pair of antennae. Head, thorax, abdomen, abdomen.
This is spineless Steve. He's a green shield bug. He gets a lot of teasing from his friends, Femi the frog and Hisham the hedgehog, because he has no backbone. But Steve, like all insects, has his exoskeleton armour, allowing him to be a big softy on the inside, but with healthy boundaries. Steve's tough exoskeleton protects him from predators and provides him with camouflage to hide among the green leaves he lives on. He'll actually change colour to become a darker brown in the autumn to blend in with the autumn leaves. How do you grow when you have such thick, tough skin? Well, Steve just pops out of his exoskeleton when he's had enough to eat. He inflates a bit until he's bigger, and then he waits for his new skin to harden into an exoskeleton. When does an insect have a soft body? As Steve demonstrated, just after he has shed his skin, he has a soft body, which he has to be careful to protect from predators. But also, some insects are born as caterpillars or larvae, and these squidgy little guys have soft bodies. Consider the life cycle of Brina the butterfly. They started off in an egg and hatched out into a soft, squidgy caterpillar. Brina is a small tortoiseshell butterfly, and this species can only eat nettles. Many species of butterflies, moths, beetles have very specific food plants. That's why it's so important that we let all the weeds grow and not just the pretty flowery ones. When Brina has had enough to eat, they turn into a shiny chrysalis. This one looks a bit like a mummified Pikachu to me. Inside the chrysalis, the caterpillar completely turns to mush, and then somehow it reforms into the shape of a beautiful butterfly. Out they pop, looking absolutely magnificent. I'm out hunting bugs in our vegetable garden. I think I know where I can find some cabbage white butterfly caterpillars. Over here on our Brussels sprouts plants, which is part of the cabbage family, we certainly do have plenty of these little chaps. Here they are, munching away at the leaves, just as I suspected. So this species is, as I mentioned, the cabbage white butterfly caterpillar, and it can devour your cabbage plants. So this is an organic farm, and we don't use any pesticides to kill off the caterpillars. There are quite a few of them, which is bad news for this poor Brussels sprouts plant, but good news if you don't like the taste of Brussels sprouts. But there's another insect which can help us to protect our cabbages from these caterpillars, and it's called a parasitoid wasp. So these wasps lay their eggs inside the caterpillar. The eggs then hatch out into little larvae, a bit like the caterpillars themselves, and they'll eat the caterpillar from the inside out, keeping it alive. It's kind of gruesome. But eventually, when the larvae are big enough, they'll pop out of the caterpillar and make their own little pupae. At this point, the caterpillar's mind has been taken over by the larvae, and they actually think that they need to protect the pupae. So they'll spin silk to wrap them up, and then they'll stand over them and defend them, waving their heads around like a snake, until sadly the caterpillar will starve and die. That means there'll be fewer butterflies and then fewer caterpillars to eat our vegetables the next year. It's all part of the web of life. Here are some old cocoons from the parasitoid wasps. They would have made the caterpillar crawl up to this point in the corner of the polytunnel, before emerging and forming these little cocoons. Creepy, aren't they? One of the things we do here at Cool to protect our vegetables from insects is to plant flowers that attract things like hoverflies, whose larvae will eat aphids, that's grainfly, and parasitoid wasps. Here's some coriander we planted next to our kale to try to attract the parasitoid wasps, but it hasn't been successful yet. As you can see, some of our kale got a little bit eaten. There's a caterpillar right there as we speak. But what can happen is, if it doesn't work and help the first year, there may be a boom of parasitoid wasps next year because we had so many caterpillars this year, and maybe we'll have more helpers next time.
Now, caterpillars have biting mouthparts for chewing leaves and flowers, but when they grow up as butterflies and moths, they have a long tongue called a proboscis, and this is perfect for slurping nectar out of flowers or gulping down the sugary poops of greenfly from the surface of leaves. Delicious. Steve, on the other hand, has a straw-like mouth, which he uses for piercing leaves and berries to drink out their juices. You'll find plenty of Steves on the blackberry bushes at this time of year. Beetles have chomping, biting mandibles for eating a really diverse array of foods. We even have one species of rove beetle which can shoot out its jaws to catch other insects. Some insects bring food home for the kids, such as bees who carry pollen on their back legs and nectar in their stomachs to regurgitate into the cells of the hive. And then there's wasps. Who doesn't love wasps? With their stylish warning stripes and their excellent flying skills. Wasps perform many useful functions. They're really helpful to have around the gardens. They dispose of dead plants by chewing them up to build their papier-mâché nests. They pollinate flowers, helping them to produce seeds and fruit. And they catch insects which might otherwise be pests and devour our vegetables. They bring these back to the nest to feed to their larvae. And in return for this, the larvae produce a sugary substance to feed to the adults. Keep that in mind the next time you bring your parents breakfast in bed. However, in the autumn, all the baby wasps have grown up and there's nobody to feed sugar to the adults, who are also all dying off for the winter. Only the queen will survive the winter by hibernating. In fact, one of them tried to hibernate in one of my curls while I was trying to lead a nature walk once. It was quite a special moment. The queen will build a new nest in the spring. But I think we can understand now why wasps are so cranky at this time of the year. Pollinators and the flowers they feed on have a really special relationship. The flowers have evolved to attract insects using colours and scents that appeal to them. But once the flower has been pollinated, it doesn't want bees wasting their energy coming back to it. Chestnut flowers start off yellow, a colour that attracts the bees, and then they turn red when the bee has done her job, a colour which bees can't see. That way the bee will only be attracted to the yellow flowers which haven't yet been pollinated. It's very efficient.
Here's a little bumblebee pollinating a borage flower. And bumblebees are particularly fantastic pollinators for this shape of flower because they do a little buzz. It's called buzz pollinating, which shakes the pollen out of the flower in just the right way for this kind of plant. Tomatoes and potatoes have similar flowers. And there you can see her pollen baskets on her back legs. She packs the pollen onto her legs to carry back to the nest. Bumblebees live in smaller nests than honeybees. They'll have about, I think, 100 to 400 worker bees, whereas honeybee hives can have tens of thousands. Having different tastes in food allows insects to avoid competition and have enough to eat. But insects and other arthropods have adapted to have a whole range of other survival tactics as well. For example, there are ants who farm aphids and fungi, hoverflies whose larvae live underwater with a tube for reaching the air at the surface, and millipedes who release a nasty smell, a bit like antiseptic, when they're disturbed. All of these wonders exist just in the UK and Ireland, and that is just the tip of the insect berg. Start studying insects now and you'll be fascinated and entertained for the rest of your life.
We are bringing about their decline through pesticide use, habitat destruction, climate change, and over-tidying our gardens. Habitat destruction, climate change, and over-tidying our gardens. Habitat destruction, climate change, and we are bringing about their decline through pesticide use, habitat destruction, climate change, and over-tidying our gardens. Forget pros up.
Am I thinking Antoinette falling off?
Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen. Six legs, maybe wings, and a feather. 1, 2, 3, go. Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen, 6 legs, maybe wings. Head, thorax, abdomen, abdomen. Head, thorax, abdomen, abdomen, 6 legs, maybe wings, and a pair of antennae. Head, thorax, abdomen, abdomen.
Thanks for watching and don't forget to subscribe.